Hello students. So in this video, I will discuss a very good question from electrostatics. See, this question is, there is a long wire and there is a uniformly charged ring. This wire is also uniformly charged. So this wire has charge density lambda 1. This is the charge density of the wire, and this ring has charge density lambda 2, and they are separated by a distance 2r, where r is the radius. So center of the ring is at a distance 2r from the wire. So question is, what is electrostatic force between the wire and the ring? Okay, so you can attempt this question. ठीक है, आप लोग वीडियो को पॉज करके और इस क्वेश्चन को अटेम्प्ट कर सकते हैं, एंड इफ यू कैन नॉट सॉल्व देन ओनली लुक एट द सॉल्यूशन दैट आई एम गोइंग टू प्रोवाइड हियर. Okay, see this question I made, or it might be present in some books also. I have not seen it in any book. I was preparing actually some questions for our upcoming concept booster course, which is going to start from 1st of November. तो उसके लिए हम कुछ क्वेश्चंस बना रहे थे, तो वो इलेक्ट्रोस्टैटिक्स के, तो उसमें से ही एक क्वेश्चन हमने ये बनाया था. सो आई थॉट ऑफ आई डिस्कसिंग इट हियर. तो देखिए, ये क्वेश्चन बहुत डिफिकल्ट नहीं है, बट इट रिक्वायर्स सम इंटीग्रेशन टेक्निक. अगर आप इंटीग्रेशन कर पाएंगे तो आप आंसर निकाल सकते हैं. इफ यू कैन नॉट डू द इंटीग्रेशन देन यू विल नॉट बी एबल टू गेट फाइनल आंसर. ठीक है, सो लेट अस डू इट. ओके, तो देखिए, ये कोई पॉइंट चार्जेस तो है नहीं, तो कुलॉम्स लॉ वगैरह से तो डायरेक्ट आंसर आएगा नहीं. ठीक है, तो हम लोग ये आप देखिए कि इन्फिनिटी लॉन्ग वायर है, इधर भी इन्फिनिटी तक जा रहा है, इधर माइनस इन्फिनिटी तक. ओके, और दिस रिंग इज प्लेस्ड नियर द मिडल ऑफ द वायर. ओके, तो हम लोग जानते हैं कि एक लॉन्ग लाइन चार्ज का इलेक्ट्रिक फील्ड क्लास 12 से पढ़ते आ रहे हैं हम लोग. ठीक है ना, इसका इलेक्ट्रिक फील्ड जो होता है, ठीक है ना, इस वायर से जो इलेक्ट्रिक फील्ड होगा ना, दिस विल बी इक्वल टू लेमडा अपॉन 2 pi epsilon naught and r, where r is distance of any point, okay, from the wire. Okay, जैसे मान लीजिए हम यहाँ पे फील्ड निकालना चाहते हैं, सपोज आई वांट टू कैलकुलेट हियर, तो ये डिस्टेंस अगर r है तो फील्ड यहाँ पे इतना होगा. इसमें चार्ज डेंसिटी लेमडा 1 है, सो वी कैन राइट हियर लेमडा 1. ओके, so because of this field, this ring will experience force. So to calculate force on the ring, what I'll do is I'll take a small element on the ring. Okay, तो यहाँ पे हम एक element ले लेते हैं यहाँ पे. ठीक है ना, इस तरह से suppose we are taking element at angle theta. ठीक है, और this element is suppose making subtending a small angle d theta at the center. तो इस एलिमेंट का जो लेंथ होगा ना, देखिए यहाँ पे लेंथ dl जो होगा दैट इज इक्वल टू r d थीटा होगा, और इसके ऊपर चार्ज जो होगा dq दैट इज इक्वल टू चार्ज ऑन द एलिमेंट विल बी lambda 2 and multiplied by dl, because charge density is lambda 2, which is uniform here. Okay, and dl can be written as r d theta, so this becomes lambda 2 r and d theta. That is the force on the sorry, that is charge on the element. So therefore force on the element जो होगा df will be equal to dq, this charge, and electric field of the ring, which is equal to this much. Okay, now see this element, if you calculate distance of this element from this wire, okay, ये जो distance होगा यहाँ से यहाँ तक, okay, तो यहाँ तक देखिए 2r हो गया, and this ये जो distance होगा ना, ये r cos थीटा हो जाएगा. ठीक है, या आप ऐसे भी कह सकते हैं कि देखिए यहाँ पे दिस एंगल इज थीटा, सो दिस एंगल विल आल्सो बी थीटा. तो ये जो डिस्टेंस होगा यहाँ से यहाँ तक, दिस विल बी आर कॉस थीटा एक्चुअली, बिकॉज दिस इज रेडियस आर. ओके, तो ये आर कॉस थीटा है. तो यहाँ पे स्मॉल आर की जगह पे, मतलब डिस्टेंस ऑफ दिस एलिमेंट फ्रॉम द वायर आप अगर कैलकुलेट करते हैं, तो दिस इज कमिंग आउट टू बी 2r एंड प्लस दिस डिस्टेंस इज आर कॉस थीटा. ओके, तो इलेक्ट्रिक फील्ड को हम ऐसे लिख सकते हैं यहाँ पे, दिस विल बी lambda 1 एंड डिवाइड बाय 2 pi epsilon naught, and here in place of r we can write here 2r plus r cos theta. Okay, that is the electric field at the location of element that we have taken. Okay, so therefore see, if you consider any element, since field of the long line charge near the midpoint is radially outward, okay, तो इस डायरेक्शन में फील्ड होगा, तो सभी एलिमेंट पे, okay, on every element force will be away from the wire. Okay, so force on every element will be in same direction, so we can just integrate it like a scalar. Okay, so force will be equal to integration dq and electric field. Okay, so let's put the value of dq from here, and electric field, this electric field will put. Okay, so this will become equal to dq is lambda 2 and r d theta, And electric field is this one, lambda 1 and divide by 2 pi epsilon naught. And r we can take common and it will become 2 plus cos theta. Okay, so that's the electric field. So we are starting, we are measuring angle from this line. Okay, तो आप इस तरह से इंटीग्रेशन करेंगे पूरे. Okay, over the whole ring angle will change from 0 to 2 pi. Okay, so we can take the limit 0 to 2 pi because we are starting from here. ठीक है ना, and we will take one round. Okay, so angle will change from 0 to 2 pi. Okay, so that is the force. So let us just rewrite it. Okay, so this force is coming out to be, see, this r and this r will cancel out, and you will get here lambda 1 and lambda 2 divided by 2 pi epsilon naught. Okay, this is 2 pi epsilon naught. And what is left here is this d theta. R to cancel out हो गया है, ठीक है ना. We are getting here d theta and divided by 2 plus cos theta. ठीक है, and this 0 to 2 pi. So let us call this integration as I. Okay, so this is the force. So now we have to calculate this integration. So once we calculate this integration, this is a very standard integration that we learn in complex analysis. Okay, so it can be done by other approaches also, but I'm going to do it here using method of complex analysis. Okay, so this integration is equal to d theta hai or divided by 2 plus cos theta, and limit is 0 to 2 pi. Okay, you all know that to do this kind of integration, we consider a contour which is a unit circle centered at origin. Okay, so for that we put z equal to here e to the power iota theta. Okay, तो यहाँ से आप dz निकालते हैं तो dz is equal to, इसका डिफरेंशिएशन करोगे तो e to the power iota theta and iota d theta you get. Okay, so therefore you get from here, this becomes actually z again. So d theta will be equal to dz and divided by this iota comes in the denominator and this is z actually. Okay, so this is d theta. All right. Now cos theta is actually equal to, we can write e to power iota theta plus e to power minus iota theta and divide by 2. Okay, so this e to power iota theta becomes z and e to the power minus iota theta becomes 1 by z. Okay, and divide by 2. So in place of cos theta, we can write like this. Okay, so let us put all these things in this integration and see what we get. Okay, so now let us do it on next slide. So we have had integration like this, d theta and divided by 2 plus cos theta, and limit was 0 to 2 pi. Okay, so when we put here z is equal to e to the power iota theta, you can see modulus of z is actually 1. Here 1 we have written. Okay, so if you calculate modulus of z, you get 1 here. Okay, so this is a this integration converts into integration on a closed contour, which is basically a unit circle because we have put z equal to e to the power iota theta. तो ये एक unit circle हो जाएगा, ठीक है. So put dz, we have written dz is equal, sorry, d theta is equal to dz divided by iota z. Okay, and divided by 2 plus and cos theta. See, cos theta we have written here. This cos theta is equal to this much, z plus, this is z plus 1 by z and divide by 2. Okay, so you just simplify it a little. Okay, so if you simplify, you will get here this 2 upon iota, and here dz and divided by here you will get z square plus 4z and plus 1. Okay, you just simplify it and see, you will get this. Okay, so this is a closed contour integration on a unit circle. ठीक है, this is integration on a unit circle. यहाँ पे जो integration है, this contour is mod z equal to 1, which is unit circle centered at origin. Okay, so therefore you see to evaluate this integration, we will use Cauchy residue theorem. Okay, so therefore this will become equal to 2 upon iota and 2 pi iota and 2 pi iota and residue within contour. ठीक है ना, residue within contour we can say. Okay, or sum of residue, whatever. So to find the singular point within the contour which is unit circle, what we will do is we'll put this denominator equal to 0. ठीक है, तो यहाँ पे let us call it, ये अभी हम लोग इंटीग्रेशन evaluate कर रहे हैं. So let us call it equation number 1. Okay, so here if you to calculate singular point, what we will do, we'll put z this z square plus 4z plus 1 equal to 0. तो यहाँ से z का वैल्यू आ जाएगा -4 प्लस माइनस, दिस है क्वाड्रेटिक इक्वेशन एक्चुअली, प्लस माइनस रूट अंडर बी स्क्वायर, सो दिस इज 16 माइनस 4ac करोगे तो यू विल गेट 4 एंड डिवाइड बाय 2. ओके, so z is equal to coming out to be minus 2 plus minus root under. So this will become 12 and you divide by 2, so you will get root 3 here. Okay, so this is what we get. So if you take minus sign, okay, so minus 2 and minus root 3, its modulus will become more than 1. Okay, so that singular point will basically lie outside the contour. हमारा जो contour है, this has radius equal to 1. Okay, यूनिट सर्कल पे यहाँ पे इंटीग्रेशन हो रहा है, तो यहाँ से अगर दोनों नेगेटिव साइन लेते हैं तो मॉड z इज ग्रेटर देन 1, सो दैट मीन दैट सिंगुलर पॉइंट इज नॉट लाइंग विद इन द कॉन्टूर. ओके, तो हम लोग यहाँ पे रेसिड्यू जो निकालते हैं, वी कैलकुलेट रेसिड्यू एट सिंगुलर पॉइंट्स विद इन द कॉन्टूर. ओके, so therefore we will take here z is equal to minus 2 and plus root 3. ठीक है ना, we will take plus root 3. So this is the singular point which is lying within the contour. All right, so therefore what we get here is this z is equal to this much minus 2 plus root 3 we have. All right, so let us calculate residue at this point. Okay, so we are calculating residue at minus 2 plus root 3. Okay, so this is basically pole of order 1 hoga, because it is a quadratic equation and there are two singular points. Okay, so once at each singular point, singularity will be of order 1 actually. Okay, तो इसका रेसिड्यू निकालने के लिए बस हम लोग ऐसा कर सकते हैं, दिस इज इन बेसिकली न्यूमरेटर बाय डिनोमिनेटर फॉर्म में लिखा हुआ है, तो वी कैन जस्ट डिफरेंशिएट डिनोमिनेटर बाय z, so we will get here residue will be equal to this is 2z plus 4. Okay, 2z plus 4. We have differentiated this denominator with respect to z. This is a technique for calculation of residue. Okay, and we will just put z equal to this much here. Okay, so this will become equal to, ये जो residue निकलेगा यहाँ पे देखिए, residue will be equal to 1 divided by 2, and in place of z we are calculating this. Okay, we are calculating residue at this point. Okay, z is equal to minus 2 plus root 3. So this in place of z we are putting minus 2 plus, अच्छा ये रूट 3 है ना यहाँ पे रूट 3, and then we have here 4. Okay, so therefore this minus 2 multiply होकर minus 4 हो जाएगा, so that will cancel out with this one. Okay, so you will get here 1 by 2 root 3. So residue is coming out to be this much, 1 by 2 root 3. Okay, so therefore this integration will become equal to, see iota cancel out, so you get here 4 pi, so it is 4 pi. ठीक है ना, and okay, so this integration is 4 pi and multiplied by 1 by 2 root 3. Okay, we have put the value of residue here. Okay, see iota we have cancelled. All right, so this gives you integration is equal to this is 2 pi and divide by root 3. Okay, this 2 will cancel out, so that is the value of integration. Okay, so now let us put this value of integration in the expression of force. Okay, so this was the expression of force here. Okay, this one, so here we just have to put 2 pi divided by root 3. Okay, so therefore we will get here force is equal to, see force we have written lambda 1 lambda 2 divided by 2 pi epsilon naught, and this integration, so we have obtained the value of integration. Okay, so therefore let us write here itself. So force will be, or let's write on another slide. So force is going to be this we had written lambda 1 lambda 2 and divided by 2 pi epsilon naught, and there was integration. So this is lambda 1 lambda 2 and divided by 2 pi epsilon naught. Okay, and this integration is 2 pi and divided by root 3. So 2 pi cancel out. Okay, so you get here lambda 1 lambda 2 and divided by root 3 epsilon naught. Okay, so this is the force. Okay, between the wire and ring. So see, the question was this: there was a wire which has charge density lambda 1, it is infinitely long, and there was a ring here. Okay, this has charge density lambda 2, and here separation is r. Okay, sorry, radius was r, and here the separation was 2r. Separation is 2r. Okay, so question was what is force between the two, so we have calculated it. Okay, and force is coming out to be the same. Okay, ठीक है, तो इससे रिलेटेड अगर किसी को कुछ क्वेरी है तो आप कमेंट्स में पूछ सकते हो. ठीक है ना, आई ट्राई टू रिप्लाई टू योर क्वेरीज. ऑलराइट, एंड एज आई मेंशन्ड दिस वाज, ये क्वेश्चन हम प्रिपेयर कर रहे थे अपने अपकमिंग जो कॉन्सेप्ट बूस्टर कोर्स है उसके लिए, तो उसी प्रोसेस में ये क्वेश्चन हमें ध्यान में आया कि वी कैन मेक ए क्वेश्चन लाइक दिस ऑल्सो. ठीक है, बट एग्जाम में हो सकता है कि ये क्वेश्चन नहीं भी पूछा जाए, बिकॉज इट इन्वॉल्व्स सम मैथमेटिकल कैलकुलेशन. ओके, बट यू नो वी स्टूडेंट शुड सॉल्व दिस काइंड ऑफ क्वेश्चंस, क्योंकि आप देखिए इससे आपको ईएमटी की अंडरस्टैंडिंग तो बिल्ड होती है, एंड आप मैथमेटिक्स जो आप सीखते हो उसका एक एप्लीकेशन भी हो गया. सो दिस इज अ गुड क्वेश्चन, ओके, फॉर बिल्डिंग कॉन्सेप्ट्स. ऑलराइट, सो दैट्स ऑल इन दिस वीडियो. ठीक है, थैंक यू फॉर वॉचिंग.